So for this first lesson of Unit 3, we are going to be talking about the very basic trig identities that exist. So first of all, what in the world is a trig identity? So a trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression is defined. So this means that we are going to be doing a lot of substitution. And so this means that one side of the equation can replace the value on the other side. So you can use identities to help evaluate functions, to simplify expressions, to verify identities. It has a lot of uses. And we will even be solving equations here before long as well. So today we are going to be talking about the most basic identities. So first you have our two quotient identities. And so these have to deal with tangent and cotangent. And so our quotient identity for tangent of theta is sine over cosine. And this is just like the unit circle. And cotangent is also just like the unit circle too, because cotangent is cosine theta over sine theta. Now, cosine and sine, depending on what function it is, cannot be 0 because that would make the function undefined. And that is never okay, no matter what the identity. So then you have the reciprocal identities. And so we have talked about this before, and this has a lot to do with what functions are friends with other functions. So sine can be expressed as 1 over cosecant as long as cosecant doesn't equal 0. Cosine can be expressed as 1 over secant, and tangent can be expressed as 1 over cotangent. Cosecant can be 1 over sine. You have seen these three before. Secant can be 1 over cosine, and cotangent can be 1 over tangent. So this is all just pretty much putting that function as equal to 1 over what its friend is. So this is just what we're going to do to be able to simplify basic expressions. So let's go ahead and take a look at some of those expressions. So for number 1 here, we're going to use the quotient and reciprocal identities to find each function value. And so we are given that secant of theta is equal to the negative square root of 30 over 3. And we need to find cosine theta. Well, one thing we know is that we have some reciprocal identities that deal with these two functions. We have that secant theta is equal to 1 over cosine theta. And we also have that cosine theta is equal to 1 over secant theta. So we are actually looking for cosine. So we are going to use that side of the reciprocal identity. And so we have that cosine theta is equal to 1 over secant. So this is going to be 1 over the negative square root of 30 over 3. And that is going to be equal to 1 divided by the negative square root of 30 over 3, which means that we can take this fraction, because we're multiplying by a fraction, and flip and multiply. So we have 1 over the negative 3 over the square root of 30, which is negative 3 over the square root of 30. And then we just have to rationalize. So we'll have negative 3 over the square root of 30 times the square root of 30 over the square root of 30. And that gives us negative 3 square roots of 30 over 30. And we can simplify this to the negative square root of 30 over 10. And there we go. So for number 2, we are given that if tan x equals the square root of 2 over 4 and cosine equals the negative square root of 2, negative 2 square roots of 2 over 3, then we need to find sine x. So what we are going to use for this is we are going to use that quotient identity of tan x equals sine x over cosine x. So we are given that tan x is the square root of 2 over 4. So we're going to take square root of 2 over 4 and substitute there. We're looking for sine x. And then we are given that cosine is the negative 2 square roots of 2 over 3. So what we can do now is we can go ahead and we can cross multiply. So we have 4 times sine x, and then we have square root of 2 times negative 2 square roots of 2 over 3. So this is going to give us 4 sine x equals the square root of 2 times negative 2 square roots of 2 over 3. And then we are going to multiply. So we will have, 4 sine x, and that equals, square root of 2 times the square root of 2 is 2. And so then times negative 2, that gives us negative 4 over 3. And then we're going to multiply by 1 over 4 because that's the reciprocal, which cancels out the 4. And then our 4's will cancel. And so sine x equals negative 1 over 3. So then let's go ahead and take a look at number 3 now. So we're still using this quotient and reciprocal identities. And we are given that cosecant of beta equals 7 over 3 and cotangent beta equals negative 2 square roots of 10 over 3. And we need to find secant beta. So we, of course, need to remember that cosecant is friends with sine. So we should be able to flip over our cosecant and actually have sine, which is 3 over 7. So we also know that cotangent is equal to cosine over sine. So this is what we can use to find secant. We'll just have to find cosine first, and then we will have to flip it over to get our secant. So we are going to plug in what we do know. So we do know that cotangent is negative 2 square roots of 10 over 7. And then that is going to equal, let's see, we're looking for cosine. So we have cosine beta over sine, and we know that sine is 3 over 7. So we are going to go ahead and cross multiply. So we will have negative 2 square roots of 10 times 3 over 7. And that is going to equal 7 times cosine beta. So this will wind up being negative 6 square roots of 10 over 7 equals 7 cosine beta. Wait, that was over 3. I am sorry. I copied that down wrong, and I just realized it because I'm like, we are not going where I thought we were going. So that one is 7, but then we have a 3 here. Okay, that is much better. And then we will go ahead and multiply by that 1 over 3 to get cosine alone. And so we have right now negative 6 square roots of 10 over 21, which reduces to negative 2 square roots of 10 over 7. And so this is our cosine. So remember that secant is equal to 1 over cosine. So we should just be able to flip over our cosine and have secant we might need to rationalize. So that gives us negative 7 over 2 square roots of 10. And then we will need to multiply by the square root of 10 over the square root of 10. That equals 7 square roots of 10 over 20. And so our final answer here is negative 7 square roots of 10 over 20. So now let's talk about the Pythagorean identities. So you have 3 of these that you will use this year. The top one is one that you need to make sure that you remember for calc, and it is probably the most common. So definitely make sure that you know this one. Honestly, your tangent and secant will come up quite a bit too. And then your cotangent squared plus 1 equals cosecant squared. It doesn't come up as often, but you will see it throughout this unit. So do make sure that you are remembering and that you always look back at that identity sheet and make sure that you can recognize them all. So for problem 4 here, we're going to use our Pythagorean identities to find each function value. So we are going to find both cosine theta and tangent theta if sine is equal to a negative 1/3 and cotangent theta is less than 0. So what this tells us is that we can figure out what quadrant we are in. So our sine is negative. Sine can be negative in quadrant 3 and quadrant 4. And then cotangent is also less than 0. So that means that it is negative. So cotangent can be negative in quadrants 2 and quadrant 4. So this value is in quadrant 4. So our cosine will be positive. Our tangent will be negative. So let's go ahead and try to find that cosine value first. So I am going to use sine squared plus cosine squared theta equals 1. That's that first Pythagorean identity. And since I know what sine is, then I know that it is a negative 1/3, so that is squared. I'm looking for cosine squared, and it's going to equal 1. Well, negative 1/3 squared is 1 over 9. And so that gives us 1 over 9 plus cosine squared theta equals 1. And then we will go ahead and subtract. So we'll have cosine squared theta equals 8 over 9, because remember, when we do this, that 1 can be 9 over 9. So when we subtract that 1 over 9, that is where we are getting 8/9. So then cosine is technically not alone yet. We need to take the square root. So cosine theta will be alone now, but we now have the square root of 8 over the square root of 9, which is 2 square roots of 2 over 3. And since we are in quadrant 4, then we know this cosine value needs to be positive. So now let's go ahead and find our tangent. So for our tangent, we are going to use our cotangent squared plus 1 equals cosecant squared theta. And so we will find our cotangent, and then we will use that reciprocal to find our tangent. Now we do know that since sine is negative 1 over 3, then that means that cosecant theta is equal to negative 3, because we can use that reciprocal. So that gives us a jumping off point. So we have cotangent squared theta plus 1 equals negative 3 squared. And negative 3 squared is 9. And then we're going to subtract 1. So cotangent squared theta is going to equal 8. Then we're going to take the square root. So cotangent theta is 2 square roots of 2. And so that's our cotangent. So then to find our tangent, that is 1 over cotangent, which means this is 1 over 2 square roots of 2, meaning that we need to rationalize. So we will have the square root of 2 over 4. And then since we are in quadrant 4, we know that we also need to be negative. So we have the negative square root of 2 over 4. All right, so for number 5, we're still using those Pythagorean identities. And now we are going to find tan x and sine x if secant x is 6 over 5, meaning that it is positive, and sine x is greater than 0. So if we look at our quadrants, then if secant x is positive, secant is friends with cosine, it can be positive in quadrants 1 and 4. And then sine is also positive, and it can be positive in 2 and 1. So we are in quadrant 1. Another thing that we also know is that secant, if it is 6 over 5, then that means that cosine theta, or cosine x, is equal to 5 over 6, which could be helpful when using those Pythagorean identities. So we are going to go ahead and try to find our tangent first. So we know that tangent squared x plus 1 is equal to secant squared x. So we know what secant is. So we have tangent squared x plus 1 equals 6 over 5 squared. And 6 over 5 squared is 36 over 25. We're going to subtract 1, so we're going to subtract 25 over 25. So tangent squared x will be 11 over 25. Then we will take the square root. And so tangent x will be the square root of 11 over 25, which is equal to the square root of 11 over 5. And since this is in quadrant 1, this positive value is fine. So now let's go ahead and look for sine x. So we know that, let's see, we have sine involved in that first Pythagorean identity of sine squared x plus cosine squared x equals 1. And so we know that since secant is 6 over 5, cosine is 5 over 6. So we have sine squared x plus our cosine squared, which becomes 5 over 6 squared equals 1. So we have sine squared x plus 25 over 36 equals 1. So we are going to subtract. So we could use that 1 as 36 over 36. So sine squared x is going to be 11 over 36. And then we will go ahead and take that square root. So we will have sine x equals the square root of 11 over 6. And this is valid because it is in quadrant 1. So the last identities we are going to look at today are the cofunction identities. So the cofunction identities are a little bit different in that you have pretty much that phase shift. And so your phase shift is pretty much that difference between the graphs of sine and cosine. And you have a little bit of that shift in dealing with tangent and cotangent as well. So that is what you will see in these cofunction identities. So you will also see even and odd identities. These come in handy when you need to change sign, especially inside the trig function. So the only even functions that exist are cosine and secant. All the others are odd, meaning that to change the sign inside the function, you actually have to change the sign of the other side of the function as well. So usually these cofunction and even odd identities are paired together and you wind up using them simultaneously. So let's go ahead and look at a couple examples of this. So if you have the sine of negative theta equals negative 0.97, we need to find the cosine of pi over 2 minus theta. So what we're going to do is we are going to, first of all, get sine to where it is positive. So we're going to take the sine of negative theta equals negative 0.97. And we're going to factor out that negative that's inside. So we'll have a negative sine theta equals negative 0.97. And then we'll divide by a negative 1. And so we have sine theta equals 0.97. So then, since we now know that sine theta is 0.97, then we will substitute that in to our cofunction identity that says the sine of theta equals cosine of pi over 2 minus theta. So we have 0.97 equals cosine pi over 2 minus theta, and that actually matches what we were asked to find. So that is where we're going to leave it. So for number 7, we are going to find the cotangent of a minus pi over 2 if tangent of negative a equals negative 2.36. So the first thing we're going to do is we're going to get tangent to where it is positive. So we're going to factor out that negative. So we have the tangent of alpha equals negative 2.36. And now we have it where we can divide by negative 1. So we have tangent alpha equals 2.36. And then we are going to use that in our cofunction identity. And in that cofunction identity, we have that tangent theta, or tangent alpha in this case, equals the cotangent of pi over 2 minus theta. Now, this actually needs to be alpha. But if you notice that what we're asked to find and what our identity looks like, we have some sign issues to deal with. I'm going to go ahead and substitute. So we have that 2.36 that can go in for tangent alpha. That's going to equal the cotangent of pi over 2 minus alpha. But we're going to have to now get it all in the same order. So here's what we are going to do. We are going to factor out a negative. So this means that in those parentheses, we're going to take a negative out. And what this is going to do is this is going to switch the signs on the two things inside the parentheses. So we're going to have now a positive alpha, and we're going to have a negative pi over 2. And so we actually wind up switching the order on those. If you don't do that until later, that is fine. So this negative can now go out here. So we have 2.36 equals negative cotangent alpha minus pi over 2. And then we have to divide by a negative 1 to get rid of that negative. So we now have a negative 2.36 equals the cotangent of alpha minus pi over 2. Then for our last problem for this lesson, we have number 8. So we have a secant of beta minus pi over 2 equals negative 3.62. We need to find the cosecant of negative beta. So we are going to take our secant, so pretty much our statement as it is, and we're going to factor out that negative because we need that in a different order if we are going to be able to plug in for cosecant at all. So we will take secant and factor out that negative. So we have beta. Actually, let's see, it's going to be a negative beta now. And then pi over 2 equals negative 3.62. So that negative is going to go out. But here is the interesting part. Remember, cosine and secant are even. This means that when you change that sign and get rid of that negative, the negative is going to stay on the 3.62. So we still have a negative 3.62. So we do have secant of pi over 2 minus beta equals negative 3.62. And then we are going to substitute that in to cosecant beta equals the secant of pi over 2 minus beta. So now that we have these equivalent, we can say that cosecant of beta equals a negative 3.62 because we can just substitute in. So we do need a negative beta, so we can multiply by a negative 1, and that gives us negative cosecant beta equals a positive 3.62. And then that negative can go inside the function. So we have cosecant of negative beta equals 3.62.